All right, thank you. So my name is Sunny Ng. I'm going to talk to you about the project I've been working on for the last few months. It's called goodservice.io. Glad to be the opening act for tonight. So a little bit about me. I grew up in Toronto and I've been living in New York for the last 7 years. I'm actually a full stack engineer and I work for a company called Harry's. We sell men's razors online. So I don't really work in the transit realm for now, anyways. But full disclaimer, so I work full stack. So if you are gonna say like you're not using the right tools language for the project I'm about to present, it's like, yeah, I know, because that's not what I know how to do. So um, just a side note. And of course I ride a lot of trains. So that photo, by the way, was from the Metro Museum in Tokyo. They have a picture sticker because it's Japan. And they have a lot of cool trains in Japan. So if you haven't gone to Japan, go check it out. All right, so a big thing that happened in 2017 was on New Year's Eve, Governor Cuomo announced that subway countdown clocks are available at all stops. And previously, they were only available on the number lines and also the L train. But now they're at every single station. Sure, some of them may have questionable accuracies, but they still provide us with enough good information to see when the next train is about to come. But with great power comes great responsibility. Um, Now, riders are regularly exposed to sometimes horrendous headways and huge gaps in service. And so on Twitter, I noticed that a lot of people were kind of mocking the MTA's website for claiming service is good service when the service wasn't actually good. And so I even made a tweet myself. So I decided, you know what? I know how to code. The data is open. Why don't I like automatically detect these situations? So instead of being surprised, although not really sometimes, by the time we get to the station, um, how about like we know in advance what routes have bad service so we can plan to go on an alternative route if that's available. And so, what are these situations that we're talking about? Well, we know what they look like, right? Based on the tweets that we've seen, it's like big gaps in service, irregular headways. So headways is basically the time between trains that are arriving at the station. So if the time between stations are getting really, really big, we should be able to notify a user about that. And the best way to compare if a headway is irregular is to compare it to the published schedule timetable. And so what I did is I went to the MTA website and signed up myself for an MTA developers account. And there were a couple of things that really was necessary for what I needed to do. And so one of them was basically the real-time feeds. So a bit quick overview of what real-time feeds are. They're basically on Google's GTFS RT standard. It's used by many transit agencies around the world, and it's basically what drives the real-time arrivals on Google Maps. They use so MTA uses protocol buffers. There are like 9 endpoints to hit, which I don't know why, but they update every 30 seconds. So we can get information like this. So the feed contains what they call trip updates, which basically describe trains that are currently operating. And so this is an example of what a trip update looks like. So this is an A train that is going in a direction 0, which is uptown. And this was at I took this around 9:37 a.m. on a random day that I took. And so as you can see, the main part that we really care about are what they call stop time updates, which is basically the stops this train will make in the near future, so until the end of the line, basically. So this is an A train that is going express. As you can see, it's going to stop at 125th Street all the way up to Inwood, and obviously it's express, so it skips all the stops between 59th Street and 125th Street. And based on this data, we can kind of figure out that the train is somewhere between 59th Street and 125th Street because the timestamp is between the estimated arrival time. We don't really know exactly where it is, but it gives us a good enough estimation that we can kind of guess. And so another piece of useful information is the static feed. It uses GTFS standard. It updates every few months. This is basically the published schedule. It's a zip file of CSV files. They don't update very often, and it includes things like like published stop times for weekends, holidays, and weekdays. Unfortunately, it does not account for planned service changes. And I've been told apparently that New York City Transit also published weekly amendments in other places for these schedules, but they update them pretty often and they're kind of hard to find, so I just never use them. And so, okay, so now I have the real-time feed and static feeds. I figured out, okay, like what am I going to do with this data? Well, so the initial implementation of this app was to identify key stations, basically stations that a lot of routes go through. And then I would calculate the actual headway, which is basically the estimated arrival time of the key stations and a delta of that. And then I also take the scheduled headway, which is basically the delta of the stop times from the static feeds. And then I compare. And why do we need to compare, you say? Well, because sometimes we forget that sometimes the MTA schedules pretty terrible headways on weekends. So for instance, like a lot of trains actually run every 12 minutes on Sundays. But if you just look at the clock, you may not know that, but it actually means it's doing fine. So this is what the initial implementation looked like. It doesn't tell us a lot. And there are several issues with this. First of all, it seems like the minimum headway isn't really that important, right? If I'm trying to get to somewhere, I don't really care if I can luck out by waiting 2 minutes versus if I have to prepare myself to wait for 18 minutes. And that's the reason why also median and average aren't even that important either. Now, A train is also kind of weird because it has branches. So 18-minute could just be like one of the branches on like Lefferts Boulevard and not the main line. So that's not really important to know depending on where you are. And then also there are other issues with this too. So routes can be really long. For instance, the A train runs 98 minutes on schedule. And so what that means is by the time, let's say like 10:30 rolls around, the schedule at the terminals are actually switched to midday schedules, while in Midtown, they're still on rush hour schedule. So the frequency will vary quite a bit at that moment. And also, incidents sometimes only affect certain parts of route as well as certain parts of or certain directions. Um, and again, trains get rerouted a lot. So like just because an incident has happened on one part of the route doesn't mean it affects the entire route. And another thing is like a lot of times the headways are actually uneven, even if they follow the schedule. So this is an example. This is pulled from the MTA report of the G train back in 2013. And basically, F and G trains they share tracks on the Culver line, but they have different headways because the F is much busier than the G train. And as you can see, the F train has pretty even like 5 minute headways, but the G train, because it has to accommodate the mergers, it sometimes it has like 5 minute headways, sometimes it's 9 minute headways. And so we kind of have to figure this out and say, okay, maybe if like we see like a 9 minute wait on the G train, it's actually not bad. It's actually what we expect. And so another idea I had was, okay, well, if we need to separate routes by different segments, why don't we use like the traditional lines? So for instance, the A train, there's the part that goes on by itself in Washington Heights, but it joins the D train at like 145th Street, and so that's like the Central Park West part, and then it runs on 8th Avenue, and then it kind of shares tracks with the C train down in Lower Manhattan, and then it goes to Fulton Street, and then it branches three ways after that. So if we were to split by lines, there are still some issues with that. Routing changes all the time. Sometimes it's to the schedule. For instance, the A train runs local at night, but runs express in the morning. Also, well, schedule data can help us a bit, but they tell us what things are supposed to look, but things aren't always as planned. There are planned service changes that happens during middays, weekends, overnights, and reroutes are regular. So I wouldn't want the app to only work during rush hour. I mean, also, when was the last time you've seen the M train run until midnight? Same with the B train, or so forth. And so sorry, okay, so by splitting the routes into lines, we also need to figure out. Well, we can also have a view holistically of physical lines. So if a group of for instance, if we're trying to travel to the World Trade Center here, and we can take either the C or E train, it doesn't really matter which one comes first. It's whatever, as long as a train is available, we can take it. And so if if we were to do that, we need to differentiate between local and express trains, because if it's the 8th Avenue line and the A is running properly and the C and E aren't, we need to know. So the revised implementation is this. First, identify the physical lines and then seed the key stations to those physical lines. So for instance, if a trip contains the stop at 14th Street and 8th Avenue, then we know it's running on the 8th Avenue line. We should also never assume that trains will go the normal route because anything could happen, either planned service changes or some emergency has happened. As we've seen, like the AC and F trains always switch tunnels, and also like for instance, the L train has been shortening a lot overnight in the last few weeks. And then we also need to accommodate multiple patterns. For instance, maybe certain trains are running express right now and they're about to go local, and we need to be able to check service within the hour. And then there are certain things there are certain assumptions we can actually make. For instance, like where switches are, where crossovers are. So like trains just can't randomly go local or express unless it's at a certain spot. And then also like not every line has express service, so we can also make that assumption already. And if we're doing this right, we should be able to detect planned service changes. And one way to detect if a train is local, remember on the GTFS RT data, we only have information about the upcoming stop. So if this is the Broadway line, which is the NQRW, and the list of upcoming stops has the 28th Street, that means it's for sure running local. If it has 14th Street and then like jumps to 34th Street, we know it's running express. If the upcoming stop only has if the list of upcoming stops only has 34th Street, then we don't really know what's happening. So we just forget that. And then another thing that we can get from this data is like be able to detect delays. For instance, if have you ever gone into subway station and see the countdown clock set 5 minutes and then 5 minutes later it still says 5 minutes? And this is basically what it's doing, right? It's basically checking to see what is the estimated arrival time initially and see if that number keeps going up. And if it is, then we know there's probably something going on causing the train to not move. So in summary, these are the statuses that are on good service. So delay, if a train's estimated arrival time at the terminal has increased by more than 5 minutes while in between the two same stations. Service change, if the train is stopping at different stations than what are scheduled. Not good, when the difference in maximum scheduled and actual headway is greater than 3 minutes. No service, when we haven't actually detected any trains on that route. Not scheduled, which is when trains are not scheduled to run. And one thing that really bothers me about the MTA website is it says good service for the B train on weekends when it doesn't run. So if it's not running, it's not really good. And then if none of the above is true, then it's good service. All right, so now I'm going to do a demo of the website. Okay, so this is the website. It is built on Semantic UI React, so it's responsive. And basically, this is the current data of what we see as the statuses of the current train lines here. So for instance, let's take a look at 7 train. Seems to be doing fine here. So as you can see, coming into Manhattan, the scheduled headway is a lot shorter than the scheduled headway coming out of Manhattan. And so this accounts for that. We can choose a more complicated line, like let's say, I don't know, the E train. And as you can see, it separates by lines. So it checks to see what is the headway on Queens Boulevard as well as on 8th Avenue. And then if we were to, actually, let's do this. So if we're on here, we can click on Queens Boulevard and we can like look at the view from Queens Boulevard instead. And as you can see, the express trains are doing okay, but there are gaps on the local trains on the M and R. And then let's do, so this is test data that I took over the weekend just to prove that it shows service changes properly. So this is the M train over the weekend. And as we all know, the L train has not been running over the weekend for the last month or so. And basically the M train is replacing that. And so the M train on weekends now run on 6th Avenue to 96th Street and 2nd Avenue. And as you can see, it basically is able to report that the changes have happened. And we can't really know what the schedule times are because those stops aren't supposed to be made. And so it's hard to compare. And so that's why the status is service change. And then another thing that I can show you is there's now Slack integration. So I can do There. Basically, it's the same information, but on Slack, because I usually find myself needing this information when I'm getting off work. So you can also do this, and you can even choose the line. There. Surface. Cool. And then also, there's now a Twitter feed that I created that updates every 10 minutes. So you'll see if like there are delays detected every 10 minutes. It's still kind of testing. Right now, it keeps reporting that Franklin Avenue shuttles are delayed, but I don't really know they are. All right, and then oh yeah, and then this is like me proving that sometimes I capture the delays before the MTA does. Okay, so what's next? Okay, so this is a screenshot that I took over the weekend as a proof of concept of a website I had that basically maps out the weekends. Well, it basically maps out the current service onto a map. So this is from the weekend, so we see the L train's not running, the M is running over to 96 and 2nd Avenue, and so forth. Basically, we're using this the data of where trains are stopping to figure out where service is. And so other ideas on what's next. So I already talked about the real-time service map. We can also, because we have the times on when trains are stopping at certain stations, we can figure out like the speeds of the trains, whether or not they're slowing down at certain spots. And also, we kind of haven't really talked about the accuracy of the countdown clocks. Right now, we kind of like take the data as is, but we haven't really figured out if it's actually accurate. So that's one thing I can do. And maybe a mobile app, but I don't know how to do mobile apps. So if somebody knows how to do it, go for it. And that is my presentation. Thanks. So these are all the ways to contact me.